Great. I think we are live. So, hello everyone, and welcome to day three, the final day of TestMu Conference 2026. And now, if you have been with us all 3 days, you deserve a badge of your own. So, thank you so much for that. I'm Pulkit, Partner Marketing Manager at TestMu AI, and a host for this session, which is on the topic when software starts thinking, the now of quality engineering. Now, for decades, quality engineering has stood on one simple rule, that is same input and same output. Every test we have ever written assumes it, and when the generative AI has came, like the that just broke the rule, right? So the LLM applications, RAG systems, and AI agents reason, adapt, and remember using tools and work with other agents. Correctness is no longer binary, and pass or fail is no longer enough. So this session is about what comes next, how quality engineering evolves into AI assurance, a discipline about building confidence in AI systems, not just verifying functionality. Hallucinations, prompt injection, agent behavior, and the metrics that actually mean something. Now, talking us through is Chinmaya Kothari, Director of Quality Engineering and AI CoE at QualiZeal. Chinmay brings over 15 years of experience helping global enterprises modernize engineering through quality and emerging tech, and has helped shape QualiZeal's AI strategy across AI assurance and enterprise engineering, and has helped clients in highly regulated industries adopt AI responsibility with work aligned to emerging standards. In short, he has done this all in production, not just in slides. Now, three quick things before we start the session. So this session is recorded, so you can catch up and see the replay anytime you want to. Drop your questions in the Q&A box as you think of them, and we'll take them at the end. And don't forget to share your takeaways on LinkedIn or X with hashtag TestMuConf, because there are prizes worth up to $15,000 on the line. So on that note, Chinmay, a very warm welcome. The stage is all yours.
Hope my voice is clear and everyone can see my screen.
Yep, yep. We can see you, Chinmay. A very warm
Okay,
welcome.
thank you. Hey, all, good morning, good evening, good afternoon, wherever you are. Well, let's get started. We asked a system this question: will this contract clause hold up in a cross border dispute? First answer came yes, clause 4.2 is enforceable under the governing law selected. Another answer came when the second time, no, clause 4.2 likely fails, the governing law selection is ambiguous. This is same question being asked to the same system. Welcome to this topic on TestMu conference. What happens when software starts thinking? How our roles as quality engineering professionals are changing? What is it that we're getting into now? What needs to change? Let's look at it. The now of quality engineering. Let's go back a few years. What did system look like? What did we mean by testing then? Take an example. I have a piece of paper, I have a Word document on my screen. I type a paragraph. I click Control P or the print button. I get an output. Every time I do this action, I get the same output, same piece of paper, same paragraph written on it in exactly the same way. It doesn't matter where I'm operating from, whether I'm sitting in India, in the US, in Europe, wherever I am, it's every time the same output. Traditional testing has been based on this principle. Every time I'm giving an input, I'm getting an output, I'm expecting the same output if my input remains the same. That is the deterministic world. How did I test in this system? Well, again, same input, same output every time. Anytime the output changes, for me, wearing my testing hat, that looks like an issue. An issue, let's go ahead, log a defect. That's how we operate. Log a defect, assign it to a developer. Developer will look at it, fix it, send it back to me as a tester. I'll retest. If it passes, we close the defect. If it does not pass, we fill it again and send it for fixing again. That is the premise that we've been brought up in as quality engineers. You pass a test case or you fail a test case. That's all we've been known so far to. What changes now is this. Come a scenario where I'm using a translator now. I have a paragraph, the same paragraph, but I feed it to a translator. It translates it, gives me a translation as paragraph A. I do it again, feed the same paragraph to the translator, and I get another response, which is response B. I do it again, and I get another response. Three different responses for the same input, and arguably all are correct. There's nothing wrong that I can really figure out in all those responses. Well, that's just what translators do. You've put in interpretation, and that's what is now changing in our world as well. With coming of AI and generative AI, systems are becoming very strong. They are not only generating content, but they are also interpreting and then giving you responses basis that. And the whole paradigm of testing now changes. You give same input, but you get a different answer every time. That's how the translator world changed. That's how our world has changed with the advent of AI, generative AI, and now agentic AI. What happens when I'm using a generative AI system? Well, let's see this. An instruction was given to a model, LLM model, saying delivery within 30 days of order confirmation. Well, when the model responded, what it said is delivery within 30 days with a full refund guaranteed for any delay. Well, what changed? My input was simple. It was one single statement with 6, 7 words. Words got added, the meaning got changed. It became very different than what I had sent. That's what hallucination does. You're giving something to the LLM, it comes back with a response which is super confident, very well formatted, grammatically correct. But then, in this case, as with many other cases, the confidence does not mean correctness. The answer looks correct, appears correct, but may be very different than what you anticipated or expected. And at times, it is even what you anticipated or expected, but it's still wrong. And that's where we need to be very, very careful when we are dealing with these generative AI systems or AI that generates. Let's look at another example. Agentic systems. All of us are referring to agents day in, day out these days. To agent A, I gave an input saying ship this assignment by Friday. Agent A talked to agent B. Agent B read it as ship it with a high priority. Agent B talked to agent C, and another statement came out, which is ship immediately with override checks. Initial statement was just ship by Friday. What came out eventually of the system is ship immediately with override checks. Very different meaning by the time the message came from the first agent all the way to the third agent. What's happening here? My message is drifting. That's another failure mode for AI. AI and generative AI have different modes of failure. The system can behave incorrectly in multiple ways. We've all heard a lot about hallucination, but that's just one of the failure modes. We've heard of drift, that's another failure mode, but just one more failure mode. There are multiple failure modes for AI and generative AI systems. There's bias that can come in, there's inaccuracy that can come in, your safety can be compromised, your PII and PHI can be compromised. There are multiple ways or multiple failure modes for AI and generative AI system, and that's what we are looking for. It's no more one input, one output, or one correct answer. Now, your answers can all be correct and can all be incorrect. It's up to us to decide how do we figure out how close we are to that correctness that we are seeking. That's where the role of tester really changes in the world of AI. And that's the now that we're talking about. How do you ensure in such a scenario that whatever response I'm getting from a generative AI system is really trustable? I'm using the word trustable. I'm no more using the word correct or incorrect. And that is the paradigm shift that we're talking about when we are talking of an AI system. In the world of determinism, we were always looking at accurate, inaccurate, pass, fail, right, wrong. In the world of AI, it is no more just one or two things that we need to look at. Now it's about overall trust. How do I trust a system? It's difficult, but then we've been able to crack it at QualiZeal, and that's what I'm going to walk you through now. There are different trust attributes that you need to look at when you're looking at an AI system. Some of the things worth looking at: reliability. Does the system consistently mean what it says? Does it consistently gives me the accurate response? Security. Is there a possibility that someone can slip in a different hidden instruction to my AI? Human oversight. Is there enough human involvement to make sure that whatever I'm seeing in the system, there's someone overseeing it? There's a human eye looking at it. There are many trust attributes that have been defined this way. What a NIST AI RMF, the National Institute of Standards and Technology, has come up with its own AI risk management framework, and it calls out 6 different trust attributes. We have a few test attributes that we have defined within QualiZeal: reliability, safety, explainability, security, privacy, faithfulness, human control. These are all different trust attributes which all need to pass for you to eventually say that this is a trustable AI system. Even if one fails, your system is not trustable. Now, how do I even look at these trust attributes and validate those to see if they are passed or failed? That's where the framework comes in. You need to look at 4 different steps or 4 different areas within the framework. We start with a risk. What is a risk? By definition, if something can go wrong, that's a risk. What we need to do and what we've done is for every trust attribute, what are those different risks that my system can get exposed to? For example, if I'm talking about reliability as a trust attribute, where can it go wrong? Hallucination is where it can go wrong. If the system starts hallucinating, what goes for toss is the reliability of the system. Similarly, if I'm looking at a RAG based system, and if I'm looking at the citation that comes back to me, the citation sufficiency, if that goes for a toss, that means again my accuracy or my reliability is getting affected. So for every trust attribute, we need to figure out what are those risks that I need to be mindful of and define those risks so that I know where all can the system fail when I'm looking at a particular trust attribute. Well, this is an area that everyone and a lot of us are researching on right now to figure out what are those risks that my AI system is getting exposed to. Next, I figured out the risk, but then the important part, how do I measure that risk? It's very difficult. It's a new risk that I'm identifying. Like, for example, if I have to ask you, how do you measure hallucination? Well, I can think of what hallucination is, but then how do I measure it? Well, you need different metrics, and we have defined 170 odd metrics, and we are still building on those to define different types of ways in which we need to measure these risks. Hallucination, for example, one of the ways it can be measured is hallucination rate, which is, by definition, the number of times the system hallucinates versus the number of times you ask the system to respond. So that's where you need to define different metrics to make sure I have ways of measuring what kind of risks my system is getting exposed to, and then how do I measure how it's performing against that risk. Now again, even if I'm able to measure hallucination rate and test for it, how do I know if this is the right hallucination rate for me? Will it happen that I am either 0% hallucination, where it's always an accurate response, or is it a possibility that I can get 1 out of 900 responses that is incorrect or that has a hallucination? Well, generally, when we're looking at an AI system, There is every possibility that it will hallucinate every now and then, and you cannot stop it. That's how AI and generative AI systems are defined. It's by design that they can hallucinate. So then what do I do in this case? That's where comes the important part of figuring out what are my thresholds. Remember, in our deterministic testing or in traditional testing, we always have an exit criteria. A lot of times, I've written that exit criteria in my test strategy, which says in UAT, a 95% pass rate means the system can go to production. Where is that 95% coming from? Well, that's my threshold for my UAT pass rate. I'm just saying, as long as my pass rate or number of pass cases in user testing are 95 out of 100 or more, I'm fine putting this system into production. Similarly, when we are testing AI, for every metric that I'm measuring, I need to come up with a threshold, that comfort level that I can define, so that I know if my metric goes beyond or below this particular threshold, that's when the question of me not trusting the system would come in. I'll retake the hallucination example. So if I've defined my threshold for hallucination, that is, I'm saying if my system hallucinates or gives me a generated information which is inaccurate 5 out of 100 times, I'm still fine with the system going into production. What does that translate to? Is the system, if it is 95 times correct out of 100, I'm still fine taking it to production. But then, if that number comes to 94, that is 6 times out of 100, the system gave me a hallucinated response, I am not fine taking this to production. That's when the system needs to go back to the developer. They need to take a look at it, work at it again, and then send it back to me as tester to now retest for that particular metric, which is hallucination rate. I look for it again, and only when my hallucination rate goes below 5%, that's when I say, yeah, this is the right system now for me to take to production from a hallucination perspective. Well, this is just one risk and one metric. Understand that we need to test this across different risks and measure different metrics across each risk, and that's where the complexity and the amount of testing that needs to happen with AI systems really increases. And as QE professionals, we need to be really mindful of that. So I've done risk, I've defined metric. Next part is to test. Testing is where I'm actually measuring that metric for that particular risk that I identified. So the hallucination rate, for example, the formula being number of times the system hallucinates versus total number of times the system was asked question. So I need to have a sufficient amount of questions that I'm asking the system, and I should have my ground truth set against which I'm validating if the response that is coming back is hallucinated response or it has some groundedness in the ground truth that I've identified. As long as the response that comes back is grounded in the data that I've grounded, I'm good. The system is not hallucinating. As soon as the system starts giving me a response that is not found in the ground truth, that's when I know the system has started hallucinating. And that's what I'm testing for. Within our framework, what we are also ensuring is all of this gets packaged as evidence and then becomes your audit trail. So you don't only test, you don't only identify the risk, you don't only measure the metric, you don't only test, you also document the evidence as part of the framework. And that's how the full traceable system is built, which gives you the confidence that, yeah, this is something that I've tested for a trust attribute, and I can say, that my tests worked fine. Now, when I'm talking about trust attributes, I'll have one question here, and I know participants cannot answer back to me, but then the question is, if I'm okay with one trust attribute, having looked at say 3 or 4 different risks for that trust attribute, having looked at 10 different metrics for that particular trust attribute, having seen that every metric has passed the threshold test, and I'm saying eventually that this particular trust attribute is good enough for me to put the system in production, Is that a fair statement? Well, it's not. It is just one trust attribute that we've tested for. There are 6 other trust attributes that we need to test for and ensure that the system passes each trust attribute, and each trust attribute passes the test that we've put it against. Only when all the trust attributes that we've defined across all the risks that were identified, across all the metrics that we've defined to measure those risks, only when all of them are above the threshold that we've defined can we say that all trust attributes have passed and I have a trustable system that can then go and sit in production. Is it fair for me to say that I want a system that is 100% trustable and only that system to be put into production? Well, if we were looking in our traditional method system or in the deterministic testing paradigm, maybe that was an accurate statement that we could still deal with. When I say accurate statement, that is something that is still achievable in a deterministic world where I'm looking at 100% trustability. When it comes to AI, achieving 100% trust is again utopian. Like how you would in deterministic testing, you would figure out a way how much testing is enough testing. Same thing we need to do with testing of AI as well. You cannot test everything. So that's where I also need to have a threshold for my trust score itself. Across all trust attributes, if my final trust score comes out to be, say, more than 95%, that's when I'm okay putting the system into production. So that threshold applies to the final trust score as well, and that's how the whole paradigm of testing of AI gets complicated. And that's what we need to really appreciate, that I need a trustable system, which means I need to be mindful of all trust attributes. I need to be mindful of all risks, all metrics. I need to test for all of them and then pack that as evidence to eventually get a trust score which is beyond my threshold. And that's when I'm fine putting it into production. Within QualiZeal, we've been able to crack that, and we have our own framework and system that will help you get through that. What has changed in the current world, we'll just reiterate here. What we used to do in traditional world is like akin to doing proofreading. If a document has been shared with me for reading and for proofreading, what I'll do, I'll look at it, look for errors, and that's what I would do. And if there are errors found, I'll send it back to the creator that these are the errors. I've proofread the document, please correct those and send it back. But now is no more about proofreading. I need to check for facts. Whatever I'm getting with these AI and generative AI enabled applications needs to be checked for facts. Is the response I'm seeing accurate? That's just one part of it. Is the response that I'm seeing fair? Is there biasness in this response? Is there a possibility that it is fetching information from somewhere where I have not even provided that as information for it to fetch from? That's what your RAG enablement does, right? For a lot of us, we'll know RAG as retrieval augmented generation. So when I'm creating a repository and I'm using a RAG based system to fetch information from that repository, how do I make sure that it is fetching the information from that repository only and not creating information? So that's where the fact checking part comes in. Is the information that I'm seeing from this RAG enabled system, is it really grounded? Is it really available in the repository that I've created, or is it fetching it from somewhere else? That's where you'll see when we're testing for RAG enabled systems, citation becomes a very important risk and metric. How much am I able to cite from the source is an important thing for me to track. The more I'm able to cite, the more I'm able to prove that yes, I'm looking at the right system and I'm fetching the information in the right way. But then that's not enough. Even for citation, there are two kinds of things that I'm looking at. Citation sufficiency. Out of all the number of responses that I've received, how many really even have a citation? That's citation sufficiency. Say out of 100 times, I, I, I hit a RAG based system, and the response that I've got, 95% of the times it has a citation, 5% times it does not. So my citation sufficiency comes to 95%. That's one part of it. Now I got a citation, but is that the right citation? Is it looking at the right paragraph in the document and the right line? Or did it just cite something that is, yes, in the document, but not related to what I'm asking? That's your citation accuracy. So it's not enough to prove that I have something that is from the document that I'm citing. I also need to prove that it is the right citation or the accurate citation. So we need to appreciate the fact that things have really changed when we look at systems which are AI enabled or generative AI enabled. And there's a lot of thoroughness that needs to happen when we're testing these systems. That's where RMTE comes in. For every trust attribute, figure out what is the risk that I'm getting exposed to. There can be one or more. How do I measure that risk? Which are my metrics? Again, there can be more than one metric for each risk that you're talking about. How do I measure those risks? Through testing. What tests do I run? And how do I come up with the measure of that metric? And then once I've done that, is the metric that I'm getting, is it passing the test of threshold or not? Only when all metrics have passed the threshold test, that's when I say I've built a trustable system. And me as a QE professional gives my certificate saying that yes, this is a trustable AI system. What we saw initially, what the translator was doing, it said clause 4.2 is enforceable as the first response. And then it said clause 4.2 likely fails. Well, that's not a bug. That's what translators do. Translator is just translating information along with some interpretation. When interpretation comes in, the responses change. That's how those systems are designed to behave. That's how generative AI systems are designed to behave. They generate information. So there's always a possibility that what you see on the system is correct from the system perspective, but then what we need to validate is this the accurate information that I'm getting? So the question was never and is never now that can the system answer, but is the answer that I'm seeing, can that be trusted? I always try and quote this example. In general, whenever you are posing a question to an LLM, hardly ever does it say I don't know. It always gives you a response. It's now up to us to make sure and validate if that response is accurate or not. Same input, different answer every time. That's what translators do. That's what generative AI enabled systems do. It's up to us to check and make sure that the response that I'm getting passes all tests of trustability. And that's when I know the system that I've built is really trustable. Translators are allowed some creative license. They can get creative, but too much creativity and what you see on your screen is not really translation, it becomes fiction. For AI, we haven't yet decided what is that thin line beyond which AI becomes fiction or responses by AI becomes fiction. So that's an open question we all need to ponder on. And I think a lot of us are already pondering on as to when do I say what is that creative liberty that I can give to AI and what is it where I need to stop it so that I can say, this is now the trustable system that I've built. We'll continue having this conversation. The conversation has just started. How do I make sure that the AI that I've built is trustable? This is Chinmaya Kothari, Director within QualiZeal for Quality Engineering and AI CoE. Thank you for attending the session. Thank you all. You have a good day. Good night. Pulkit, over to you. Hey, Pulkit, I cannot hear you. Are you on mute?
Can you hear me now, Chinmay?
Yes, yes.
All right. Apologies. I think that was error from my end. Yeah, so I was saying, Chinmay, thank you so much. That was a brilliant session, a perfect one, I would say, to call this edition of the TestMu Conference 2026. And yeah, the idea that will stay with me throughout the session, that is the ground rule of a professional, like same input and same output is gone. And the answer isn't is to test harder; it's to change what we are building. That is confidence in the system with evidence and not just a green tick on the test case, right? So yeah, so on that note, I think I saw that the question Q&A box was buzzing a lot. So I think we have time. Let's take some questions.
Mhm.
So Chinmay, I'll just pin some questions on the screen and I'll then decide it and then you can answer.
Sure.
All right. We have one from Bharat. So let's take this one. So how do you validate an agent's tool selection before allowing it to execute actions against production systems?
Well, that's where you need to, and I'm audible, right?
Yeah, you're audible.
Yeah, yeah, but that's where, again, there are different metrics for tool selection as well. Is it, looking at the right tool? We have to validate against how many times does it, call a particular tool,
Yeah,
and every time we need to measure, is it the right tool or not? Again, based on a threshold, we need to ensure, if again 95% of the time it's the right tool, uh, and that the threshold is the question mark right now. How do I decide that threshold? That's where, multiple people need to come in. Generally it can be your risk manager who can define that. It can also be a new role that can be defined, from an AI perspective. But once that threshold has been decided, that's when every time you're calling this, every time you're invoking this agent, you need to see which tool it is, selecting, and
yeah,
then you do it multiple times. Once you have certain level of confidence that, out of say 100 tests, all 100 times it select the right tool, maybe that's when, or basis the threshold, that's when you decide, okay, this is always calling, or this is calling the right tool within my threshold, and that's when I say, okay, this system works. But that's how you need to do it.
great. Thanks. And let's take another one from Prachi. That is, how much human intervention is typically required before an AI generated test can be trusted in production?
That's again, how much is difficult to answer. It will depend on what is the system archetype that we're looking at, and what is it that the system is supposed to do. For example, if I'm looking at a system that does not deal with any kind of PII or PHI, my tolerance of it going wrong would be much higher. uh, I can bear with it going wrong a few times because there is no PII PHI that can get exposed. But then if I'm looking at a system that is dealing with PII PHI, even one occurrence of that information getting leaked is very high for me. So the amount of testing that I need to do varies, depending on the usage, or the usability of the system. What is the use case for which we're using that system, and what is it that goes into that system and comes out? For systems that are, say more internal, say if I'm creating a chatbot for internal usage within my organization, my tolerance for it going wrong again would be higher. Whereas if I'm creating it for external facing audience, for customers for example, my tolerance will be very low. So it's not just one single, number that we can have. It will depend on, what is the definition of that system, who is going to use that system, what kind of information it is going to give out, and all of that together will define, what my threshold for that particular system would be for different metrics.
All right. Yeah, I think we have the next one from Emma, and I think that's a pretty interesting question here. So, if we meet again next year, what do you predict change the most?
uh, well, if we meet next year, I hope this theory goes a long way, and I'm one of the pioneers in testing AI. But jokes apart, it's a very fast moving world. We are imagining within our firm as well. Things are moving really fast. We are building things, from a testing perspective, trying to make sure we are able to test every kind of AI system and getting ready for future to do that. Uh, and what we are looking at is, AI being the the game changer, and testing of AI being the bigger game changer. A lot of activity to happen on that front. 1 year down the line, maybe we have uh, at our end at least a product that will do all of this for you. You don't need to manually do much. You just provide your information to the system and it does all the testing for you, gives you a trust score. I think if I'm able to do that, I'll be in a happy space, and we'll be selling that product to multiple people.
Great. Another one we have is from Abhinav, and that is, how do you test an agent's decision-making process and not just its final response?
Yeah, so interesting that you asked that. So there are layers to an agent. You need to test every layer. For example, if I if it's a RAG based agent, for example, if it's fetching information through a repository, uh, you need to check for one, whether it's fetching the right information. uh, that's the retriever. Then is the right context getting created? So that's another layer. uh, then is there context when it's getting created? Is it rendering accurately when the response comes back from the LLM? So there are these multiple layers, and each layer needs to be tested for every trust attribute and every metric that you've defined for that system. So that's where it cannot be that I give an input and I look at the final output from the agent, and I just verify that. You have to go through every layer, and that's where when we are testing AI systems, every time, that's what we are talking about when we are defining the test strategy. Your strategy should look at, first thing, the architecture of the system that you're trying to test. uh, Whatever is the number of layer, we need to go to the least level, or the maximum level of detail, to figure out what is that first layer, the second layer, how many layers are there, and each layer needs to be tested for all of these attributes. Only when each layer is trustable, your final system is trustable. And that's how we need to test for it. Figure out the architecture, figure out the different layers, and for each layer do the testing. And then only you can say that whatever you've built, whether it's a RAG based system, whether it's an agent, whatever it is trustable only when it passes all its layer passes the test of trustability.
All right. I think we have one last question from Paul, and that is confidence and correctness together the most powerful and effective combination?
um, Depends on what system you are looking at. Again, if it's a mathematical operator or a system that you've built to calculations, maybe I'll say yes to that question. But now, say for example, if you've built a system to filter out resumes for your talent acquisition group, uh, I'll be more mindful of whether the system has a bias, an inherent bias, where it can create results where it shows that it is favoring one kind of demographic versus another demographic. So it depends again on what kind of system, what is the use case, and where are you using it. uh, just saying one attribute or one single element is the most important one will not apply. We need to be mindful of the archetype that we're looking at. We need to be mindful of the purpose of the system that we're looking at, and multiple things define what can be the most critical element. That's where, even within our framework, we allow the user to set weights for each trust attribute. For some systems, for example, the talent acquisition filtering system, faithfulness maybe is a more important trust attribute as compared to the accuracy. Whereas for a calculation based system, the accuracy part becomes, has to have greater weight than faithfulness. So that's how for every system, you can have different weights or different importance or priority given to each trust attribute. And you need to define that for you to be able to test it thoroughly. But then there's no one single attribute that we can say applies to all systems. It is very dependent on which archetype and which system and which use case you are testing.
All right. That's, I think that is it. What we have like in terms of questions today.
Hmm.
So, yep. Thank you so much, Chinmay. Like that was a very insightful and a fantastic session to have on a final day. And yeah, so now, like, so if you have any more questions, guys, you can just make sure to ask us on our YouTube channels, or just drop it in the chat, and we'll make sure to post the takeaways and answers on the YouTube channels itself. And yeah, so make sure you do post your takeaways from this session. Tag Chinmay, QualiZeal, and TestMu AI. And yeah, hopefully, like, we'll be seeing you next year, like, with the maybe Chinmay with some role or
Yeah.
something. Yeah.
Yeah.
So yeah, that's it for us for this session. And this year we'll be starting the closing note in 30 minutes. So yeah, see you all there. And
Sure.
yeah, thank you so much, Chinmay, for joining in. It was great having you in this session.
Thank you. Thank you, Pulkit. Thank you, everyone. Have a good day, good night. Happy weekend.